All right, let's get an example and some vocab and some conventions in your notes here. So if you'll open your binder back up to this page. First, I like to just explain to you and have you listen and concentrate. Next thing I like to do is have you kind of go along with me for an example or two and write some things down. So let's start here. Let's get to some vocab first. There's going to be an example coming. You can see it at the bottom of the page, but let's start here. So the first thing is you're going to hear me use this word solution set. I'll come back to that in a minute. Down here, let's contrast some things here. So variable equations like this that we did before, those have one solution. Like when you look at this, y plus 2 equals 5. The only solution is y equals 3. We call that a solution. There's only one of them. Inequalities have a lot of solutions, actually an infinite number of solutions. So we change that equal sign to, say, a greater than sign. The situation is different here. Y plus 2 is greater than 5. Well, what makes that true? Like 3 doesn't quite. That makes them equal. But 4 would work, 5 would work, 6 would work, 7 would work. All those numbers are going to make it more than 5. So variable inequalities don't have one solution. They actually have an infinite number of solutions. They have lots of solutions. 4, 5, 6, 7, and anything up all the way to infinity would happen there. So like rather than just saying y equals 3, which is a single solution, this is any number more than 3. And there's an infinite number of those. So rather than having a solution, inequalities, we say, have a solution set, a set of numbers, a huge set of numbers that make them true. So a solution set is all the numbers that make an inequality true. And you're going to hear me say that a lot for the rest of the year. There's a different, equations have a solution, inequalities have a solution set, a whole lot of possible numbers that y could be in that case. So that's some vocab. Let's do an example here so that you have one really nice one to look back at when the time comes. So 3 times m is less than 15. You notice I made the inequality pretty simple because I want to do like that. So I like to start with the solution set version. You don't have to. It's the one I find the easiest to start thinking about what the numbers are. So I like to start by what would make them equal. What would make 3 times m equal to 15? That one's not going to be a solution here, but it's going to help me find all the ones that are. I might be able to do it. I might just be able to look and be like, yeah, 3 times 5 is 15. Got it. If you can't do it, you can just use the inverse operation. 3 times m in the problem, I would find that number by doing divided by 3. And of course, that's 5. So once I have that number, that's where I start. I'm like, okay, let's start with 5. Now, in this case, 5 is not a solution, but it's almost a solution. So I like to X that out because it is important, and I like to show my reader, I know it's not quite 5, but like 4.99 would be okay. And I'm going to start listing from there. So not 5, but 4 would be fine. 3 times 4 is 12. That's less. 3 times 3 is fine. That's 9. That's less. Same with 2. Same with 1. ... Even all the negative numbers. So any number less than 5, but not 5, will be fine. I put it in braces, and I also like to remind my reader I know that it's not just the whole numbers, but all the fractions and decimals in between these numbers as well. So that's the solution set version there. I usually next go over to the number line because it kind of works the same way. You'll notice here I want to do 4. I want to do 3, I want to do 2, I want to do 1. I also want to do all the numbers in between those and all the numbers less. It's like I'm putting an infinite number of dots on this number line as far back as I want to go. Now, that's not yet all of them because there's some numbers between 4 and 5. 4.5 would still work. 4 9/10 would still work. 4.99999 would still work, just not 5. So the way I show that on my number line is I go right up to 5, and I show that I'm going to go right next to 5, but I'm not going to shade 5. So I put an open circle around it like that. The reason I put that circle is to show very clear I'm not shading it. I know 5 is not shaded, but 4.999 is. Do that very clearly. You use an open circle when 5 is not a solution. If I had this in my problem, less than or equal to, then 5 would be a solution. And then I would shade it in. We would call that a closed circle. So if I had this, I would shade the circle. But since I don't shade it because 5 is not quite a solution. So you use a filled or a shaded circle when 5 is a solution, and an open circle when it's not. So in this case, it's not. So that's my number line version here. Next, I'll go to the inequality statement. You've noticed here I say m can be any number less than 5, but not 5. Here, m can be any number less than 5, but not 5. So same thing here. M can be any number less than 5, but not 5. I'm not going to put that. M can be any number less than 5, but not 5. This is the one that gives people the hardest time if you want to put a star by it. I'm not sure why. People don't usually like that one. They usually like to use these 3, but this one oftentimes confuses them for some reason. But it just shows me all the numbers they can be. M can be any number less than 5. Last but not least, I can just write that out in words. M can be any number less than 5, but not 5. I like to put that in there at the end, but not 5. If it could be 5, I would say it can be any number less than 5, including 5. But here, I would not include it. So that is how they go in your notes. Okay. I'm going to ask you to pause here and do one with your group. So you may have to wait for your group to finish this notes example in their notes. That's fine. You have plenty of time today, I think. So I'm going to ask you to do next. I'm going to put one on the screen for you and your group to do together. I like to call this that you do together. So you can just do this on some scratch paper, on the back of something, wherever you have some space is fine. I want you to talk about this example that you see here. I've given you the word version for and any number greater than 4. I want you to find the inequality statement, the number line, and the solution set. If it were me, I would do the solution set first, then the number line, then the inequality statement, but y'all don't have to. So pause the video here so you can see the example, and when everybody at your table is ready, talking an example over together is really good for your memory and your understanding. So do that with your group now, and then unpause when you're ready.